Hi, good day. This is grade 12. This is the exam of 2019, paper 2, and I'm going to do question 8, only B1 and B2. So B1, it says we have to prove that Gn equals to Ne. But first, before that, let's see what do we have. So they give us the circle, they give us the points H, G, N, E that is on the circle. They say the center is O. So always keep in mind when they say the center is O, then we are going to do something with that. We have a tangent here at the bottom in C. So let's just highlight the tangent. Let's make that a different color. So that's a tangent over there. And then we have GB is parallel to NC. So where's GB? Is this over here? So that's parallel to this NC. So this NC is a tangent and is also parallel to NB. So I'm just keeping it different colors. They say HG is equal to HE. So where's HG? There we go. It's equal to HE. Maybe make that also color. So HG is equal to HE, and then they say GON is 2x. So that's this angle over here. That's 2x. Okay, so we have to prove that GN equals NE. So where's GN? GN is this over here, equals NE. So the two blue lines we have to prove must be equal to each other. So I can already, so how my approach usually is to start from the question to prove that two lines, the blue lines, are equal to each other and see what can we prove. So what I am going to try to prove is that this G1 equals E2. This G1 equals E2. Because if I can prove that, then I can prove that this is a isosceles triangle, meaning this two lines, GN and GE, will be equal to each other. So let's see what do we have. So we have this 2x over here. So I'm just seeing 2x, and I'm also seeing this here, tangent chord theorem. So if you look at the tangent chord theorem, it means this N3 will be equal to G1. Remember, N3 is part of a tangent, and there's also the chord NE. And if you look at this here and goes all the way to the other side, then that will be equal to each other. So let's keep that in mind as well. Okay, so let's see what can we do. So that's 2x. If you look carefully, if that is 2x, it's extended from chord GN, and the same GN, let's just do this. So GN is over here. It extends to the center O, which is 2x, but the same chord also extends to an angle on the edge of the circle. And if you have that, then the rule is that the center, which is 2x, is 2 times this. So if the center is 2x, that one, and then E2 is x, because they have been extended from the same chord GN. So if you just follow the curly green that I drew, right? So at least we have that is x. So what's the next step that we can do? So if that is x, so we don't have that yet, and we don't have that yet. Let's see if we can do something. Keep in mind, this is a, what do you call it? These two are parallel. So they always, if they give you a parallel, see if we can use it somewhere. And I'm going to use it here. I'm going to say E2 equal to N3. So why do I say that? Because I'm just going to do this. So if you take the yellow and you just extend it this way and like that, then that angle is equal to that one. So this angle over here will equal this. So let me just draw it separately. You have the two parallel lines. You have this angle here. That means this angle in that corner will equal that angle over there. So that is what I have here. So there's the parallel line, GB, parallel line NC. And that means that angle in the middle equals that. So in 3, that's also going to be equal to X. And you can just say alternate angles of a parallelogram. That's a reason. Always put a reason down. Now we actually started to say, using the tangent chord theorem, we already identified that in 3 is equal to G1. So that means G1 is also equal to X. Remember the tangent chord theorem? This is part of the green tangent in C, and it's part of the blue chord in E. So it extends to G. So that means N3 equals G1, which equals X. And now you can see G1 is X. E2 equals to X. That means Gn, the blue line, equals Ne, the blue line. And you can just use the angles in isosceles triangle is the same. So you have the isosceles triangle and the two sides are the same. That means the two angles in the corner are also the same. All right, so that is a Gn, to prove that Gn equals to Ne. For matric, I don't write everything down. I'm just going to explain it because when now you know the reasons, I'll just talk about the reasons. You can maybe just pause the video, write down the reasons, and continue. So I'm just trying to get as lot as possible in. Okay, so that's the first one. What's the second one? So the second one, they ask this one here, prove that a triangle GON. So before we do that, I'm just going to try just to clear some of the things out, just to make some space here. There we go. Okay, so what do they ask now? So now they ask, just keep in mind that's X, X, and this, that's also X. So now they say prove that triangle GON. So where's GON? So it's this one here, GON. So prove that that is congruent to GHE. So where's GHE? GHE. So let's make that a different color if we can. There we go. And make it green. GHE. So GHE is the green triangle. The red one is GON. We must prove that is congruent. So to prove it's congruent, we must either prove that 3 angles are the same, 3 sides are the same, or side, and an angle. But what I'm going to, you can already see the one triangle is much bigger than the other one. So I'm going to try, I'm going to do it here. Going to try to see if I can get that 3 angles are at least the same. So let's see how we can do that. Right, so here we already have a 2x. So let's see what can we do. What can we do with the 2x? So if that is 2x, then we already said that that is equal to x. So let's look at this part over here. So remember, this is a cyclic quad. So if this is a cyclic quad, then there's something that we can do with a cyclic quad. There's x and there's x. Let's just focus on this n1 plus n2. Let's just go to the next, and then just draw it separately. So I'm looking at this part here at the bottom, n1 plus n2. So if we have that, so let's do the triangle differently now. So it's like that. So if that is x and that is x, then this over here will be, let's call it y. So that y will equal, so if you look at it, y, the whole, if you do it, I'm going to do it this way. So x plus y equals 180. Which is the 3 insides of a triangle. And if they're all equal to 180, then y equals 180 minus 2x. So that means this over here is 180 minus 2x. So we are not talking about this part over here. It's 180 minus 2x. Now, if you look carefully, like I said earlier, this is a cyclic quad. And H2 is the opposite of N1 plus N2. So this is actually N1 plus N2 equals this 180 minus 2x. Because we're just dealing with this triangle over here. Now, if you look at the bigger quad, then H whole angle N1 plus N2. And one of the rules is the two opposites equal 180. So that means H2 plus N1 plus N2 will equal 180. So let's just see what does it mean if we write it down? I'm just going to keep it here. So we have that H2 plus, but now it's plus this whole thing here at the bottom, plus 180 minus 2x. Let me just do it. Excuse me for this. Let me just do it separately. So that H2, that's this angle here, plus this whole angle here, which is 180 minus 2x. Those two together, so plus 180 minus 2x. Keep in mind, that two together gives you 180. Just repeat one last time. So this is two angles that are opposite a cyclic quad. And usually if the one is, for example, 100 and the other one is 80, so the one plus the other one will give 180. So I'm doing exactly the same, but this angle over here, N1 plus N2, is now 180 minus 2x. So H2 plus the 180 minus 2x will now give you 180. So if you do it, we have H2 plus 180 minus 2x equals 180. So the H2 is the 180 basically cancel each other out. So this H2 will equal 2x. And there we go. So H2 equals 2x. So now we can actually go back to this one and say this H2 equals 2x. So remember I said we needed a 3 angles. That's what I'm looking at. So this triangle, GON, the red triangle, already has a 2x, and now that one is also a 2x. So that's something that we can start off with. So let's see what else can we do. Right. So next up, let's look at this. We have a 2x, and here's also 2x. But as you can see, here's an isosceles triangle, the green triangle, and the red triangle is also isosceles. Why do I say so? Because OG is a radius, and ON is also a radius. So OG equals to ON. Right? So OG equals to ON, both are radiuses. But if this is 2x, and that is 2x, and because in the green triangle, you have the two sides that are the same, that's given. And in the red triangle, you have the same sides that are the same given. That means this E1 will equal N1. Because the 2x equal each other, that means this E1 will equal N1 as well. So if E1 equals N1, and the reasons you can just say they are angles in an isosceles triangle. So if you look carefully, we have the 2x. We have proof now. So we have the H2 equal to that 2x over there, the O. We have the E1 equals to the N1. And automatically the other triangle, the other angle, G1 plus G2 in the red triangle will equal G2 plus G3 in the green triangle. So just make sure you can see that. We have two angles that are the same. There's 2x and N1 and E1. And because they are the same, it is, and if you use the maths properly, the insides of the triangle, you will find that the red one over here, G1 plus G2 in the red triangle will equal G2 plus G3 in the green triangle. And because of that, we have now proved three three angles are the same. And because the three angles are the same, we have now proved that angle GON is parallel to angle, not parallel, congruent to triangle GHE. GON is the red one, and GHE, that is the green one. So that's it for question 8. There's a lot of colors and things, but I just, again, like I said previously, I like to use the colors just to explain it properly so that we can visualize it better. Thank you very much for this. Have a good day. Bye-bye.